So if you have any doubt in yesterday's lecture, then firstly you can ask about your doubts. So if no doubt, then we can continue with the topic that we earlier were doing, that we were doing about relational algebra. Just just a minute. Yeah, let me check if you have skipped any of the topic. Meantime, you can ask your queries. We have done two parts of relational algebra queries. We have done many of the queries. If we did selection operation, projection operation, union, intersection, set difference. Now we will continue with the more examples. So we are considering this example, which is a banking example. Schema we will be considering for this that we discussed yesterday or in the few previous lectures. So same schema I am considering. So in this bank example, so first query is about, it says find the name of all the customers who have a loan and then account at bank. सो हेयर इट सेज कि हमें वो कस्टमर्स फाइंड करने हैं, उनके नेम चाहिए जो हमारे जिनका कोई लोन भी है और जिनका कोई अकाउंट भी है. So as per a schema, we will get this type of information from two relations. One is your borrower relation, another one is your depositor relation. From the borrower relation, we will get the customer names of those customers who have taken any loan, and from depositor we will get customer name of those customers who have a certain saving accounts. So by providing or using intersection between these two, we will get the record of both customers who have both loan and have certain other account. This is the simple query. We did design the query in two parts and then put the common conjunction intersection between these. So here next we have to find the customers who have loan and bank, and then we can use simple query, that is the join we can use. So whenever we are using join, we can simply write borrower join loan, the two relations that we are joining. We will simply write customer, select customer name, loan number and amount from that. We need not to do anything else in this case. This is a simplest query. Simply we will be providing the list of attributes that we want to select. So in our case, we are selecting customer name, loan number and amount. We will write them here, and, and we will use the relationship between borrower and loan. We will be joining these two relations. As we are not using Cartesian product here, so we need not to specify any condition that says giving comparison. So now we say that any query can be done in more than one way. We can write the query in two ways, three ways, or a number of ways. So in this case, we are considering to find the customers who have an account from at least the downtown or uptown branches. These are the branch cities, basically name of the branches. We are considering these two, and we will be finding the customers who are from these two branches. First query says, okay, this one is the simplest method to write the query. We will put a join, natural join between depositor and account, and then apply the condition um, on the resultant of these two table joins tuples. We will write the query, we select the branch name downtown, and from that retrieve the customers. Similarly, another condition was on uptown. So again, apply the join between these two. Apply the condition that says branch name equal to uptown, and from that select the customer name. This is the simplest and the best way to write the query, and then apply intersection because we are using the and keyword here. So whenever we are using and, then we will be using intersection. Now suppose there were a query which says to find all the customers who have an account at least either in downtown or town. Then we might have used union over here. So in this way we can write a simple query. Then the next methodology to write this query says, okay, we can use the divide operation here. So this query is basically using a constant relation. We can write the query this way. For branch name, we have two options. It may be downtown or it may be uptown. So we will put them in round brackets, and under these round brackets we have formed a set. Just like we write a SQL query which says where branch name uh, between this and this, or where branch name like this comma this. So it is working like a similar to your like clause in your relation in your SQL. So here it says uh, branch name. It may be either downtown or it may be uptown, and the results of these have been stored in temporary variable. A temporary relation has been formed, and we have used the row operation, that is the rename operation, to specify this. And then here we say by customer name, branch name, we are selecting by applying the join condition. Another example query says find all the customers who have an account at all branches located in Brooklyn City. Now the condition is on branch city. So here the branch city condition applies on Brooklyn. It says the branch city equal to Brooklyn. So what we can do? We will just select it from the branch relation. We will say branch city equal to Brooklyn, and select the customer name, branch name. So here we are saying select the branch names where branch is equal to Brooklyn. We have selected these records from branch, and based on this we are saying कि, join provide put a join between depositor and account. On performing the join operation, whatever record we have retrieved, just select customer name and branch name from that. After that, the record that was selected over here, that is customer name and branch name, divide it with the branch names from Brooklyn City that was selected over here. Next, we have outer join. So whenever we are talking about outer join, whenever we are talking about natural join, we are talking about actually equijoin, which is an inner join, which specifies the exact matching of the records. It means the result should exactly be matching. So now there comes a condition where where we may want some records that are not exactly matching. Some unmatching records are to be returned. So in that case, we will be using the outer join. So outer join is basically an extension of the join operation that avoids loss of information. So it computes the join and then add up the tuples from one relation that doesn't match tuples in the other relation to result in the next join. So basically it applies some dummy constant that are the null values. Null may stand for that the value is not existing, it that is where it doesn't exist, or it may also be representing that the value is unknown. So here we say we use null, which signifies that the value is unknown or it doesn't exist. So here we can say that all comparisons involving null are roughly speaking false by definition. Now let us move to the example of outer join. Here we are considering two relations. One is loan, another one is borrower relation. The important thing that is to be noticed about these joint relations is says okay, in loan relation we are having three loan numbers L170, L230 and L260. But in borrower relation again we have three rows, but loan number is L170, L230 and L155. So in this case, two records are matching, but this one loan number is not having any corresponding value to borrower. At the same time, the loan number L155 don't have any corresponding value in loan relation. So in total, we are having four entries for loan numbers, but the only thing is, there are two rows which is not having specific matching records in the other tables. Whenever we are performing join, then we will be the results will be varying in this case. For example, if I apply inner join, then L1 for L170 and L230 we will retrieve all the matching records, but L260 will not be retrieved. It will not be displayed in output, and similarly L155 will not be displayed in output because inner join says whenever we are performing uh, join between two tables, then it forms exactly matches and return the values correspondingly. Now here when we are performing outer join on left loan and borrower, then only these two records will be returned where L170 and L230 was matching. The another option is if we want to retrieve all the records that are even not matching, then we can go with the either outer join. The outer join is of three types. It is left outer join, right outer join, and full outer join. So when we are talking about a left outer join, this is the notation for your left outer join. It will retrieve all the values from left table, and for right table, if we have found any matching value, it will be displayed, and if we don't found any matching value, then we will be getting null in this case. Now for low number, three entries in left table are L170, L230, and L260. So here we have L170, L230, and L260. All these values are there, so these will be displayed over here also. And for customer, what we can see is that it for L260 there is no entry in right table. See, now there is no entry for loan number 260. So corresponding, we are not able to find the customer name. So here we will get null in this case. And whenever we are performing right outer join, it will be based on the right table. So L170, L230 are the common values that will be displayed. L155 exists in the right table, which don't exist in the left table. So we will be able to display the customer name, but for L155 there is no branch name or amount number, so this will be retrieved as null. Here we can see null values for these two. And then when we are performing your full outer join, it says both on left and right side it is working. So the matching records will be written as it is, and for L260 that was present in left table but not in the right table, we will get this customer name as null. And for this L55, we were not having values in the left table, so that is branch name and amount will be null in this case, and we will get case as the customer name. At the same time, I have put these handwritten notes in your classroom also, so here we can check it. Let me show you brief description of that. So in module 2, you can go to handwritten notes over here. So in these handwritten notes, you can see the description of relational model. There may be question of relational model, relation model, and you can do it from here. Then properties of relations are given in this. After that, you can get relational case that we have already discussed in the presentations also, it is mentioned, or you can go with definitions from here as well. So all types of keys there. After that, important question is on integrity constants. So the a list of integrity constants which are of four categories. So whenever we are talking about constants, we say that must hold all the values relational instances. We may include constraints, key constants, entity integrity, and differential integrity constants. Then we have domain constants, key constants, entity integrity, and differential integrity. So next we have query languages that we have discussed. That is, query languages is of two types: relational algebra queries and your relational calculus. Whenever we are talking about relational algebra, we are talking about procedural. Whenever we are talking about relational calculus, we are talking about, yes, exactly, we are talking about declarative. After that, we discussed about relational algebra operations, selection operation, example query for selection operation. Then another query, four examples are there. This, then projection operation, we did that, example queries for that. After that, we discussed union operation, examples for union operation and how they are working. Set different operation, this is being explained in the schema that we considered, that is in product, rename, set difference, natural join operation is there, division operation, assignment operation, and all outer joins. We have discussed all these terms. This is another example for outer join. You can go with both of these. Upper relational calculus that we are going to start in the next lecture. That is also present in your notes.